Hello and welcome back to Compiler Programming. In the last video, we made sure that the scopes are working correctly, and now we can look up types in those scopes, which means that we can add more types, remove types, and do all kinds of nice things. But scopes are not just for types, they are also for variables. And in particular, the next step that I want to do is I want to create an identity function. So it just gets a variable of a certain type, and it will be also hard-coded s64, and it will return that variable. So this implementation will likely take a while for us to go through, but it's okay, and it's a very necessary step. So let's get to it. Let's check if we need to have anything else done here. That actually looks fine. We should be able to make this happen. Okay. I don't think we need any changes here, which is good. That means that eventually we'll be able to abstract all of this away, and that's always a good thing. For now, the only change we need to do is this stuff needs to be s64 to s64. Same thing here, and now I do like so. Okay, so that's fine. When we run it, it will actually work. I think I know that one. It will. Let's see whether it fails. Let's try to do some TTD. Okay, so it fails on line 369, which is, yeah, which makes sense. We have no idea how to deal with the arguments. Okay, well, let's try to figure out how to deal with the arguments. Right now, I will focus only on supporting one argument, and then if we make that work very fast and the whole test is done, then we might go back and work on multiple ones. If not, that will be one of the next videos. Okay, well, the way it works is exactly the same as with the function definition, in a sense, right? That we will need to match things in this args children array. So I guess we want another state, and we would say that this is like args state, and here root is going to be args, and then yeah, that's about it. Now we can use pick functions to deal with it. So let's see which one we want to take. It is probably this one. So arguments, at least right now, before we go into pointers, arrays, and all kinds of crazy stuff, right now the type will be very simple. We just expect to have an identifier followed by an identifier. Or maybe actually no. Maybe I want this stuff. I want to say that x is of type s64. It will be, I guess, slightly easier to parse long term, and also it might be necessary very much later when we deal with generic types and so on and so forth. So let's go for this version. And I like this one more, I guess. Okay. So that means that we expect an ID. So this will be arg ID. Then, okay, we also need this delta, or delta is probably actually a bad name, pick index. Okay, so we have argument ID, then we need to have a column. So that's okay, that's very easy. So we say arg colon. And finally, we want another ID, right? So that's this stuff, but I also need to assert that we actually did have colon. If none of it matches, actually here we can't really return result. So what do we do about that? I guess one thing we can do is do another one of those functions. So we say type def struct token match arg, and we would have slice name arg name and slice type name, and we'll match. I can also just return a pointer, and then we don't need the bool match. I guess for now let's stick with what we have, but I might reevaluate that decision later on, and how in general these things are done as well. For now, I just want to make progress. Match argument. It gets all of this stuff. Okay. You know what? I will do it right now. This is now a pointer. And so here we just return 0, 0, 0, 0, 0, 0. And this is where we actually create one. So token match function star function is temp allocate of token match match function, and now we can get these things out. Okay, that's very nice. I guess we can move this stuff even further and just do value. Okay. Okay, fine. Here we have a pointer. So like so. We want some arguments. In particular, we want state. And well, just so that the measure functions are uniform, let's get the program. Maybe we will need it, and maybe we'll change how all of them work. So that's fine. Pick index undefined. That's okay. We can grab it. It was over here. And we have pick index. Return 0, 0, 0. And if we did match, we return actually token match arg results is token match arg, and then we have name. Well, actually, let's keep this arg name is arg id source, and then arg type name is arg type source, which we don't have yet. So let's add that archetype. Okay, we replace delta. That's good. Turn result here like so, and we are getting closer. We don't need this variable anymore. Okay, let's say that we have now token match arg star is token match argument of arg's state and program. What is the issue? Yeah. Okay. If arg do something, right? That will get rid of error at least, but we still have now errors in here, but that's fine. This is pretty easy to fix. We just turn them into pointers. That means we can do this stuff. And the same thing over here. Of dots to arrows. Okay, great. First, let's check that we haven't broken the first test. Unexpected value. Where did that happen? 432, unexpected value. Interesting that I don't see the first test passing. Maybe just flashing doesn't work. So let me try to disable this test for a second. Okay. So yeah, it is just somehow flashing is weird when you have assertions, but that's okay. Cool. So we have a variable now. At least I hope so. What do we do about it? We need to look up the type, which is something that we can do. So basically this thing, right? Where we have type value, global scope. That's good, except it is arg type name. So that's good. And then we have a variable. And this is where we are coming into the scopes being actually used for regular variables as well. That means that every function actually needs to have its own scope, and every block as well also needs to have their own scope. And that means we need to create one. And that scope is a child of the global scope, because eventually we'll have global variables and we need to be able to use those. Okay, so let's do that. We say scope star function scope is scope make of program global scope. And now we can do scope define function scope, and we need to define a variable. So that will be arg name and the type of it, or the what will be the value of that variable? And this is actually where we make use of our existing support for this stuff. And we have these nice macros that allow us to actually create a variable of correct type. So I think there was macro for more general variable. Yeah, so we get the type and we get the descriptor. Okay, so that's something that we can do then. Let's create that variable, say arg id whatever arg value, and we need to provide it the descriptor type, and descriptor is this stuff. So this will be a bit repetitive, so I think I'll create a function to do that, but for now that's fine. So we have this and we have arg value. Great. So ideally we now have a scope with a defined variable. Okay, but we have no idea. We're still gonna explode over here, I think. We're still gonna get an expected value. Let's check that. Yeah, exactly. So we still assert here, which is expected because we have no idea what to do when we have, where is it? When we have x here, right? We don't know what that means. So let's fix that real quick. The way we do that is we add another if, and we say that if it is an identifier, then we need to try to just look up that identifier, right? If we get a value, then everything is great. If not, well, we can actually print a nice error message later saying that, oh, we couldn't look up this variable. Value star var is scope lookup of function scope and expression source. This is the variable, and we say assert var, and then okay, we assert the variable, and we need to say that body result is that variable, right? Same as we did here. So let's see what that will do for us. Okay, that is interesting. So we are asserting inside of an encoder. Okay. Let's see what is happening. That we will need a debugger and see what's going on. Okay, build debug, start debugging. And that's the wrong program probably. Yeah. Let's do that again. So we have instruction, maybe label, and we don't have a label. Is it that we don't have a label, or handle exception functions back abort? Okay. We need to go to encode instruction. No, encode function encode builder. So we are actually have a problem here. because not exactly certain. Okay. If instruction maybe label. So I guess we're supposed to have. We actually do have labels here. Maybe that is the issue. Wait a second. Label target is defined and it does have some stuff. Okay, what is going on? This happens inside of program and what? Just trying to understand what is the difference between what we have before and what we have now. Let me just look through it. Here everything is sort of fine, and here it isn't. Before we go in too long, what I want to do. Oh, actually, maybe it is just a test runner problem. Let's try that. Yeah. So what was happening is test runner uses this string as a key. So if you have two tests with the same name, then it's a problem. Maybe I should make a check that doesn't allow that to happen, but that's a completely separate thing from what we're trying to do right now. So actually everything is great. We have a thing that returns us our variable that we passed to the function, which is really, really neat. Let's stash that or save that state. And there is definitely some cleanup that we can start to be doing. So the first thing, I guess, is I want to extract something like program lookup type. And this will return actually it will return a descriptor star. And it will do all of these just that we wanted to. So we just pass in the program and we pass in the type name. So slice type name, and it will do everything for us. So we take this stuff and we put it over here and we say return descriptor. Obviously we need to change some things around. That looks good. And now we can do program lookup type, program, and descriptor. No, arg type, or sorry, type name. Okay, that's good. We can also use it over here, and that would be like so. Actually, I can also do the same here and just say that return type token source. That sounds pretty nice. Let's check again. And that's very good. Okay, so I think I want to slightly clean up this stuff as well. This is just a bit too verbose for my taste. So let's start defining some macro. And we say token yeah, let's say token match. What does this do? Well, it will basically do what we were doing here. So we say ID and we say here we'll just put it like this, which allows us to pass any parameters. And I will copy this stuff, put it here and say like so. If not ID, then return 0. Okay, we'll keep it like this. So we expect to have state and we expect to have peak index. And then here I will just do args. And this means that I should be able to just say token match arg ID, and then directly without all these braces, I can just put this stuff. Okay, let's try it on one of them. Let's run the tests. Okay, seems to be fine. Let's try it on the second one. So we say type ID, source is this. This is our colon. Okay, that looks much better to me. Much more concise and readable. Okay, and that also means that we can try to clean up this thing. So this will be not delta, this will be pick index. And we can start. ID is ID, then we have column is operator with this stuff, and then we have paren. So we have args paren, then we have arrow, right? Just arrow. And I think it also might make sense to create something like token match operator, which will just accept this stuff. So that will be a second pass of what we are gonna do. Paren. And so this is return types, and this is body, and this is curly, right? That seems good. Okay, let's try it again. And that's very nice. Now I will do this token match operator, and here I will put in operator, and it will be basically this stuff, right? So actually, let's do it like this, and then I would say token match operator, token match, and then this stuff. Okay, we pass in ID over here, operator, and I will do it like so. So this means that here we can say token match operator. Great. This is very, very nice. Very concise, readable. So I like it. And this is something I think that is very important about languages in general. Obviously, C macros are pretty horrible in the way that they are implemented and the syntax and everything, but it should be possible in your language to abstract away any kind of part of the language that you want. And this is a powerful part about C macros, I think. Obviously, in something like Lisp, it's pretty straightforward because everything is just AST. But besides that, very few languages actually allow you to do that. Rust macros are pretty great as well, and they are much more safe, but they also have their limitations where you have to know that you're calling a macro, and it has good sides and bad sides. So I don't know. But anyhow, this is very nice. We are now able to have a function that returns, that actually has a scope and it has an argument, and you can look up the argument from the scope, and it is very, very neat. I think that will be it for today. Hopefully, I will see you next time where we will tackle multiple arguments. Goodbye.